SREs at Twitter. I joined Twitter like more than 2.5 years ago. I worked on things that matter and don't matter. So I've been using Aurora since I joined, and currently working on large-scale services where like we do talk about requests per second to be in millions per second request. So.
I'm Bill. I'm a early developer on Aurora. I've been working on Aurora at Twitter since about 2010. So I've sort of been through the whole life cycle of getting the company converted, and I don't do the things like Burke does. I don't actually get to use the system, but I'm mostly focused on building the system.
Hi, I'm Josh Adams from Foursquare. The unglamorous SRE title has adorned me for some time now. I came from Google a while back, and I've always been really excited about finding some system that does what Mesos and Aurora does. And when I found out, how serious the Mesos project was, we were right in the middle of moving our Mongo installment from AWS onto hardware, and I just could not wait to get that done because it was really exciting to get started with even just playing around with Mesos. And now that we've had a lot of experience with running Aurora, we are just accelerating in terms of the amount of value we get out of it and how many services we are moving onto Aurora. So yeah, I'm just happy to be here to answer any questions about our experience.
Hi, I'm Ben. I'm an engineer at Folsom Labs. We are a pretty tiny company. We do engineering and design tools for solar panel deployments, like as in power. We're the kind of company we're a little bit too small for it to really make sense for us to use Mesos at this point, but our needs are pretty compute intensive and we expect to be growing a lot. I came from Google as well, so I've been pretty enthused about Mesos in general. It serves a lot of needs that I've been looking to fix in all the other open source stacks that I've been dealing with.
So how long have each of you been working with Aurora, just so we can kind of get a rough sense of this?
About 6 months in my case.
It's been a year or maybe even a little bit over a year for Foursquare. In the last 6 months has been the most kind of like real on the ground production usage.
Like I said, started developing about 5 years ago, started about 3 years ago in production.
2.5 years.
So I think we have really a variety of experiences with the project. Maybe Ben, you could start off as someone kind of newer to the project. Maybe you could talk a little bit about what your experience was starting off on the project, how that went for you, and specifically, what problems you were trying to solve with Aurora.
Sure. So before I got started with Aurora, I was working with Marathon, which is the other pretty popular Mesos scheduling framework. And it was working pretty well, but I don't know, there's some bugs I was waiting to get fixed. And I don't know, Aurora does a lot of stuff that I like. The updater in particular caught my attention. And getting started with it, it was really surprising to me how much more difficult it was to deploy Aurora than Marathon or the Jenkins Mesos integration. So I've been doing a lot of work on improving that in various ways. Once I got some deployment stuff figured out, like pieces have been falling into place pretty well. It's been pretty nice to work with.
Yeah, so I think like a lot of startups, you basically hard code everything onto all of your machines when you begin. Like there's really no other choice. You end up eating up resources where you don't expect because you're not monitoring everything. You can't really predict how things are going to behave as you pack more stuff onto boxes, and then you realize you're wasting all these machines. And I mean, obviously, like it's a scheduling issue. We have it with Mongo because Mongo requires you to hard code things. So we've been sort of married to the idea of like laying out our services by hand. So for a long time, we decided, well, if we're going to have to deal with Mongo, we might as well just stick with supervisor everywhere and just push things out to static groups of hosts. It was very similar to what Joe was describing with regard to attributes inside of a machine database, where you just configure, manually schedule things inside of our database, and then that's where applications go. We were afraid to move away from that because that's a very safe place to be. And as you want to iterate fast, you don't want to spend your SRE resources on something that could blow up in your face. But one thing that really helped us become even more eager and interested in the project was all the open source tools and libraries that we were already using from Twitter. We already had a lot of really great connections here, so it was kind of, we did do some evaluation of Marathon, and we found some similar kinds of unknowns, and sort of didn't really seem like the architecture of Marathon was anything as special as it seemed to be from the Mesos standpoint. And then when we saw Aurora, we were actually deciding whether or not we should build our own Aurora, and we started along the path of doing that, but as we saw the more and more as Aurora was becoming open sourced, we decided instead of building an Aurora, we should build our own config framework so that we could create configurations that would be shared across our old supervisor environment and the new Aurora environment that we were going to be able to start using. So we really were able to make some headway and put very minimal services in production on Aurora, right as it was coming out to the open source community.
Can you repeat the question?
I believe the question was, what were your initial experiences adopting Aurora? You may be biased.
Not applicable to you.
You can always pass the mic.
I didn't have a choice. I was force-fed Aurora. Well, that's true. But the initial impression is when I first joined, we had a lot of the significant portion of the architecture still running on static boxes, and Aurora was still getting more mature every day. So the cold hard truth is Aurora side sucked less, and then it turned out to be a breeze. As of today, comparing to, again, 24 plus months ago, we are in a shape that we do not have any confidence issues with the running platform, and the most importantly, as similar to Foursquare's experience, we are not wasting resources, or we're wasting a very minimal amount of resources. So it's a breeze, especially if you are standing from the site reliability point of view, when you can control the elasticity of your capacity and your time to recovery, or as godsend.
So I was obviously starting and building Aurora while we were adopting it, but I'll just give a surprise that came up during the course of developing the system, which was that the major hurdles were not technical. And a lot of people, I don't know, I try to say this often, and I think it's really true, that I think what we've built is actually not really all that novel. I think people, actually everybody, I didn't realize everybody up here was formerly at Google. But Google's not unique in that regard either. They've done it to grand scale, and I think others have done it to grand scale too. But this is the first that I know of that has actually been really successful at huge scale. But again, the major hurdles were never technical. It's always been human. It's always been getting buy-in, getting people convinced that we should commit to something. This is one of the first major things at Twitter that we actually had to get alignment amongst the whole company for something technical like that. So that was the major challenge for us.
That's actually a really good segue into some of the things that I'm interested in kind of understanding a little bit more. What are the impediments to adopting Aurora then? Are they, as you say, Bill, are these social things, basically socializing the software within the organization?
There's an element of that. There's convincing people that you are competent and able to build the system that you say that you can, which is real. I mean, there's people that are going to carry the pager and really rely on your system, so they want to have faith in it. But yeah, it's partially getting buy-in. It's partially that lots of people have different opinions about how something like this should look. And ultimately, and I've had discussions with people where they're like, oh, it shouldn't be built like this. It should be a decentralized system, not this master-slave thing. And my argument has always been, it doesn't really matter. I mean, you can start with whatever. The hardest part is getting the organization aligned and getting people behind the facade. You can change it afterwards. That's really the most important thing.
So my question is about issuing quota. So how do you go about doling out quota? What does it mirror your traditional sort of, I want to request 10 machines, so I've got to get approval from some sort of hardware request, or let's see what's my name. Oh yeah, and do you over allocate quota?
When a project starts, like, this is directly from Twitter perspective, but again, like, there's nothing novel with this one. The actual resources are owned by a capacity engineering team, people who know what they are doing about capacity. But we do come up with the initial footprints at the design review of individual services. We do expect people to write realistic load tests and also inject failure and find out their sweet spot in terms of like a single instance requirement, and then interpolate it to their expected latency and request profile. Of course, there are like error margins in here. But the science behind it is quite simple, right? We do try to balance like CPU and memory usage as well. Like there are like when you look at it, their verticals should be close to each other. Like the crazy number of CPUs, but very little memory. Like we try to make sure that they are good chunk sizes for our bin packing as well. Like they are not like oddly shaped instances. Then there's the cost model, of course, but most of our services do not fall into that cost model fences. Like they are not that large. Like the smaller services that we're launching, they don't even need any approval. But like there will be some services where they do run on thousands of instances, like consuming thousands of machines. Of course, like we will sit down with them and like, plan accordingly. But again, the science behind it is do not create very oddly shaped instances and base your decisions for quota related to your test results.
So these guys don't yet use quota. So just a little bit of background. Quota is sort of how you reserve resources in Aurora. It correlates with the production bit. It's basically how you have an input to the preemptor to free up resources in the cluster for important things. And just to add to what Burke said, one of the really important things for me being a developer on Aurora is basically the whole reason I started working on Aurora was because not because I had a deep interest in building a cluster scheduler or building like this kind of system. It was because I built some network service at Twitter and saw how horrendous it was and how long it took. And I basically wanted to defend that person that's starting up a brand new service. So this is kind of what I carry along with me, like day to day being at Twitter and also in building Aurora, is that I really want to strike a really good balance between making sure that the large scale critical services have the resources to run and are safe to run, but I also really want to get out of the way of developers and let them experiment, let them innovate, and basically not have systems and checks and balances in place to get in their way all the time. Yeah, back to the question. So related to that, one of the things that we have at Twitter is basically any developer can ask for a modicum of production resource without really anything getting in their way. It's an automated process. There's sort of some thresholds in place, and this is going to be an evolving process. But ultimately, we want to have as few humans and as little like manual back and forth operations as possible for somebody to get something into production.
Again, significant portion of the recent launching services do not even go through any human review. Like that modicum of quota is large enough that they can actually launch services that handle Twitter scale, whatever it means, traffic.
Yeah, so I actually do use quota, even though we don't really have a chargeback system or a way of accounting for costs of things, simply as a way of guaranteeing that all of the jobs that are production jobs, anything serving user traffic or backing user traffic, are guaranteed to run, which makes it low risk to run basically anything else at non-production priority, I guess. I also intend to use it as a lower bounds for some sort of auto-scaling mechanism. I'm running Aurora on AWS, which I guess Telepart is doing as well, and probably some other people. I haven't really seen somebody doing auto-scaling of the VMs backing it yet. So it's going to take some creative work to figure out like exactly what to use as the signals for that. But at least I can set a lower bounds on, production quota.
Oh, yeah, so we actually do rely on priority, the priority setting, which is totally different from quota. But we have a very flat, user layout. We just run a single production user across all of our Aurora jobs. And when we want something to run in a pinned pool of boxes, we used to have sort of a few attributes, like one positive attribute for the service that needs to be pinned there, and then a negative attribute for things to look to avoid, so that only certain jobs would be scheduled on that pool. But that turned out to be kind of bad practice we learned from the Aurora guys as far as the scheduler is concerned. So we cut half of that out, and we decided to have an attribute on the slaves where we want to pin the jobs and then have a high priority for those particular jobs so that they would kick other jobs away if they need to run. So just a side note, I didn't know if we were going to get to priority, but that's been working really well for us.
Is anyone else using priority on the panel? No? Okay. So I have a few questions that people have actually tweeted in. So we're live on the internet here, Twitter. This is a little. We're going to start to get a little bit more specific, and we can also take questions from the audience too. But someone was asking specifically about interactions with Aurora. So how does a typical developer interact with Aurora? Is it using the Mesos UI, SSHing into slaves, launching tasks, task updates manually? What does that workflow look like? And I'm genuinely curious if this is different, among you.
Well, for me so far, it's been, since I started running the Aurora scheduler, I stopped looking at the Mesos UI itself, which has been pretty great. And for the most part, interacting with tasks has been through the Aurora CLI, including SSHing into the sandbox, which is technically just SSHing to the slave, but I let the Aurora client manage that for me.
Oh yeah, so we have a sort of like a Python code base to do our server deployment management, and we initially decided, well, so there's a Python library basically that the original V1 client used, and now there's another one that the V2 client uses as an entry point. So we were able to build wheels from the Python code and then use those wheels inside of our deployment software so that we can just seamlessly decide, okay, this service, based on the service config, it knows whether or not it's on Aurora. If it is, then it will just use the wheel that's already inside of the PEX that's running to do the deployment. And that's how it interacts with the scheduler. Now, we're also excited about future changes which may remove the Python client entirely from this chain, where it could be like just a REST interface as the only way to interact with the scheduler. So we're not really sure, and I'm curious for Bill to jump in on that one. But yeah, we also use the client, the command line tool, which actually works really, really well. We have a sort of a similar kind of deployment mechanism to the rsync script that was described earlier, but it's slightly more defined. There's a wrapper around an Aurora-like script, which uses we have a internal deployment tool called Loco, and it's a way to package things into basically tarballs that are versioned, and then you can say, I want to stage the most recent version of the package or give it a version, and then it will check locally in your local Loco root, and then if it's already there, then it's a no-op, and then it'll just run the PEX directly from there. Yeah, developers can just run it directly that way, and that's been working well so far. So the question is, do any of our developers write Aurora configs? It's a really good question. So we decided to templatize everything. That was the work that I briefly described when we were originally thinking about writing an Aurora scheduler ourselves. we felt like Twitter would probably be much better people to do that, and we instead embarked on this like configuration language that's similar to the Mako or PyStash kind of world, and it allows us to share a bunch of like inheritance configuration, and so that's what actually generates the Aurora configuration.
So one thing that's kind of interesting at Twitter for users interacting with Mesos and Aurora, so as far as what they interact with, I think you'd get a real mixed set of answers. I think you'd probably get a large portion of people saying that they use the Mesos UI daily, and some that say they use the Aurora UI. In reality, the reason people say they're using the Mesos UI is because they don't know the difference. We made the mistake a long time ago of calling Mesos and Aurora the same thing, and that just has lasted forever. But in reality, I don't think there are any people other than the operations people that work on Aurora and Mesos that use the Mesos UI, simply because it doesn't really organize the information in the way that you would want, for the constructs that we apply on top of Mesos. So the typical interactions are using the job page, using the command line client. And then as far as stepping out into configuration, there's really everything that you can imagine. There's people that have built full-on platforms on top of Aurora, which is cool and frightening at the same time. There's actually, Burke here could talk about something that he wrote that we don't like very much. But there's people that are trying to simplify, and for legitimate reasons, they're trying to simplify their workflows. I think for similar reasons that Dobromir brings up, that they want to be able to do things more simply and also do more complex things without some of the boilerplate that we impose.
I think giving a Turing-complete configuration language to developers is one of the worst ideas ever. No, you don't have to. No, you don't have to. It is quite possible to give them non-Turing complete languages and limit them. And as Bill said, like the tool they hate, which for a reason I do hate it as well, is to control the entropy. It's stopping people. Like everyone comes with their opinions are like belly buttons. Everyone has one, and like they do come from startups. They do come from Google. They come from different companies, and they all believe that they know the right way of doing things. And like when you also give a very powerful language to them, they will go through their ways and build really scary stuff. I'm not a big fan of wrappers, but like we ended up creating wrappers to control the sanity of all these configuration files. All developers, not all, but a significant amount of developers do write Aurora config files. But like they have to stick with some normal and sane-looking thing because like they'll be tackled by an SRE if the SRE is not the person who's creating the crazy stuff. And like I don't even know what Mesos UI, where Mesos UI lives. All the developers and operators, we do interact with the Aurora one. And like use the command line tool. There was a question about like do we log into machines? It's strictly frowned upon. Like you should justify why you're SSHing into an Aurora host. Like if you rely on actually SSHing to us other than really complicated debugging, it means that we got something wrong somewhere.
Should we address the configuration? I don't know if you.
I addressed this as it's a crazy idea, but like what is next should be answered by Bill.
So I think actually Brian would be a better. No? Yeah, I think so. Brian says take the power out of the user's hands. I think the reason we started the way we did is because we didn't want to invest a lot of time inventing a really complex configuration language that we knew we would have to create. So that's why we just went straight for Python. As far as doing things like inheritance to make sort of common patterns possible, I think we're interested in figuring out how to make that more possible. So far, we've sort of favored composition over inheritance. That's why you see some of what you do right now. But I think the state we're in, we're not terribly opinionated as long as it doesn't disrupt, the current environment that we have.
This is about the databases on Aurora. So I think Mesos right now is working on dynamic reservations and other features that make it easier to have stateful services. I assume Twitter currently, or I think I heard Twitter does not run stateful services on Aurora. And I was just kind of wondering, do you guys plan on doing it someday, and what the roadmap might look like there?
So we have done this before, and we've done it with relative success. So Aurora has a feature where it's called dedicated machines, so you can basically pin jobs to specific hosts. And from the user's perspective, this worked really well because they got to basically feel like regular Aurora users. The reality was it put a terrible burden on our operations because we now have some set of machines that we have to treat differently from everything else and that have a different configuration from everything else. So I think that's still an unanswered question. And I think even with the persistence primitives in Mesos, this is still unanswered because it doesn't answer the realities of storage, which are you do not want bytes on a disk, you want usually like fast bytes on a disk. You want SSDs, you want RAID. So it's more complicated than I think what is currently being targeted by the persistence primitives. So I think I think something like dedicated hosts is still the most obvious answer, but it's definitely not as scalable for operations as I would like.
Just a quick comment on that. At Medallia, we're planning to try out using Ceph for storage. So we're basically going to mount up a Ceph image on the host that's going to be running the job, which decouples the storage from like the individual hosts and lets us move around more freely.
Yeah, that's actually not the first time we've heard of that, and several people have used that with good success. We don't use that at Twitter, and I honestly don't know if we ever would just because of the scale complications and frankly just amongst us unfamiliarity with Ceph. But I definitely know that is being done with good success, and it totally sort of, like you said, decouples and solves the problem.
Yeah, I'm pretty sure Mesosphere, possibly in conjunction with others, are doing something similar to that with HDFS. Not just running HDFS on the same nodes as Mesos slaves, but actually running it on the Mesos slaves, on Mesos. And that is without dedicated hosts.
But again, the key is fast bytes.
Yeah.
That's not HDFS.
Okay, we're just about out of time. I'd like to thank our panelists. Thank you very much.